All right, let's dive into a concept that really, and I mean really, separates the pros from the amateurs when it comes to design: parameters. We're going to break it all down by looking at a super fun project: building a custom arcade cabinet.
You know the feeling, right? You're hours into a project in your CAD software. You tweak one tiny little dimension, and suddenly, bam, the whole thing just explodes. Your assembly is a mess, features are broken everywhere, and you feel like you've just wasted half your day. It's the worst. But what if I told you there's a way to build models that actually welcome change?
So you're basically at a fork in the road. On one side, you've got manual editing. It's chaotic, it's risky, and yeah, it almost always ends in something breaking. On the other side, though, you have parametric design. This is all about control, consistency, and stability. This is the professional way, and it's what we're going to focus on.
So yeah, let's first take a closer look at that nightmare scenario. You know, the one where a single tiny change just unleashes total chaos. Because once you really understand the problem, the solution feels like a superpower.
And that solution is this simple but incredibly powerful idea: a parameter. In software like Fusion 360, a parameter isn't just some random number, it's a named value. Think of it like a master control knob. It's a single source of truth that you can link to different parts of your design, letting you control all of them at once.
So let's get into the nitty-gritty. What do these parameters actually do for us? How do they turn what's basically a static drawing into something dynamic and, well, intelligent?
It really all boils down to these three things. When you use parameters, your changes become intentional. You're driving the design with a purpose. They become consistent because every single part that's linked together updates automatically. And, maybe the best part, they become predictable. No more crossing your fingers and hoping for the best.
Okay, theory is one thing, but let's see how this stuff actually works in the real world. We're going to apply all this thinking to our arcade cabinet project, and this is where things get really cool.
Now, the very first step isn't about getting creative, it's about being super precise. We're going to reverse engineer an existing cabinet, which means we're measuring everything and recreating it perfectly. This gives us what we call a baseline, a perfect digital twin of the real thing. And this process is absolutely critical. First, we recreate the cabinet exactly, making sure we've captured every detail. Second, we preserve the original design intent. This is key. We're not just drawing lines, we're trying to understand why it was built that way. And third, we prepare the model so we can make smart, controlled changes later on using our parameters.
Okay, and now for the big payoff. We've built our model the smart way, using parameters. So let's see what happens when we want to make a pretty big change to it. So, how many different sketches do we need to edit? How many parts do we have to manually resize to totally change the layout of this cabinet? What do you think? The answer is one. Just one. We only need to change a single number.
And there it is. On the left, our original 19-inch single-player cabinet. And on the right, the exact same model, but now it's a 24-inch two-player machine. We didn't redraw a thing. We just went into our parameters, changed the width value from 19 to 24, and the entire model just rebuilt itself. It's incredible. So what's really going on behind the scenes here? Well, because we built it with parameters, everything that was linked to the width updated automatically. The side panels moved out, the control panel grew to fit two players, even the internal shelves adjusted their spacing. This is what we call design intent. We basically taught the model the rules from the very beginning, so all the parts stayed connected and nothing broke. See, this isn't just some clever CAD trick. This is fundamentally how professional engineers think. It's all about building systems that are tough, flexible, and ready for the next great idea.
And if you look at an established workflow, like the Project Lead the Way engineering design process, you can see how perfectly this fits in. When you're developing solutions, your changes are controlled. When you're testing and evaluating, you can easily compare different versions. And when you need to improve something, you can refine the design without having to start over from scratch. It just makes the whole process so much smarter.
And hey, if you're thinking about a career in design or engineering, this is exactly the kind of stuff that industry certifications, like the one for Fusion, are testing for. Proper dimensioning, capturing design intent, making sure your model is stable, these are the core skills of professional CAD work. So, what this all leads to is a fundamental shift in your mindset. You're not just creating a static, one-off object anymore. You're actually designing for change itself.
I absolutely love this quote because it just nails it. Parameters elevate what you're doing.
What started as just a CAD model becomes this living, breathing, adaptable engineering system. A system that can evolve and improve in an intelligent way.
So, I'll leave you with a question to think about for your own projects. Are you just building a static model that's going to shatter the first time you try to change it? Or are you building a true engineering system designed from the very start to embrace change? Thanks for tuning in.